Yesterday we discussed in the previous class we discussed on regression. Okay, so we have almost completed the part of linear regression, and also we have little bit discussed about the non-linear regression. See, in this particular we have seen that in linear regression we assume that the relationship between the dependent variable and the independent variable, it is more or less linear. Okay, and we have also discussed about the simple linear regression and as well as the multiple linear regression. In simple linear regression, there is only one dependent variable, but there is only one independent variable, sorry. And in case of multiple linear regression, there is more than one independent variables. So in case of multiple linear regression, the details of multiple linear regression, how to conduct that you can find using this particular link. Okay, the calculation part, how to find out the particular parameters, the coefficients or the intercept, that you don't need to know. Just you should know how to conduct this thing using Minitab. Okay, so I have given you the link of Minitab. You can download it from the Google Drive. If it works, then it is good, but if it doesn't work, then you need to purchase it, or you need to use the free version, which is valid for 30 days. But in case of examination, for your examination purpose, I can tell you that the Minitab is not required, because in examination only the conceptual questions will be asked. So no need of doing analysis using Minitab. Okay. And now in case of the nonlinear regression, how to conduct the nonlinear regression, you can see that there is also another link is given by means of which you can conduct nonlinear regression with practical example. But let me tell you that nonlinear regression is a huge topic. It's not very easy, because there can be different categories of nonlinear regression, and how to know that which particular nonlinear regression is applicable for your case, that depends upon, that might depend upon trial and error method, or there may be several other kinds of things as well. You can just have a look at this video, but usually you won't get too much problems on non-linear regression. Most of the cases you will get the data, the kind of problems you will have, those will be based on the linear regression. Okay. Now we have also seen that how to check whether your assumption of linearness is correct. We have seen that that's why after conducting the analysis, or after conducting the analysis, you will be getting the values of the coefficients or the intercepts, and you will suppose you will find the values, okay, coefficients or the intercepts or the constant values. Then you need to analyze the residual versus fit. If it is scattered in nature along x-axis, you will be representing the fitted value or the estimated values, and the residuals, that means the estimated values and the original values, the difference that you will be plotting through the y-axis or the residuals. And you will be seeing that if it is scattered in nature just like this, then you can understand that there is no relationship between the fitted values and the residuals. Okay, so you can conclude that the relationship is linear in nature, and if it is some pattern is noticed, then you can understand that there is a relationship between the fitted value and the residuals. Okay, that first, suppose you will see that as the fitted value increases, the residuals are decreasing, and as the fitted values is increasing, then again it is the residual is also increasing. So the relationship must not be linear between the dependent and independent variable. The relationship must be, there must be some pattern. Okay, there must be some non-linear relationship, because of which for a particular estimated values, the residual is one type, and for other residual, other fitted values or the other estimated values, it may be that the data is the residuals, or that means the actual, the thing that is changing. Okay, uh, so we can take a look at this thing, that idea will be clear. This property is known as homoscedasticity and heteroscedasticity. You can see that in case of homoscedasticity, critical assumption of the classical linear regression model is that disturbances will have all the same across the variances. Okay, you can see the uh, scatterness of the data. Okay, this data is homos uh, this data, it exhibits the homoscedasticity. But when the scatter of the errors is different, varying depending upon the value of one or more of the independent variables, the error terms are heteroscedastic. Okay, so it means here it is given the independent variable, but that will be same for the for the estimated values as well. Okay, for a particular estimated values, if it differs, the errors, if if the residuals, actually that is not error, should not be told, it is residual. If the residual is actually varies based on the estimated values, then you can also understand that the homoscedasticity is not there. The data does not exhibit homoscedasticity. The data must be, it may be heteroscedastic in nature, or it may be uh, the non-linear kind of thing, you can assume. Okay, so uh, so uh, just wait. Mm. So the same thing here also, you can see that the satisfactory model and unsatisfactory model. Homoscedasticity describes a situation in which the error terms or the residuals is the same across all values of the independent variables. And wait, hello. Homoscedasticity is assumed for many statistical tests, and we tend to test for it many procedures. Actually, the assumption is typically for the population, but of course we test the sample. We may need to transform one or more variables if we encounter strong heteroscedasticity. Okay, this will be heteroscedasticity actually, not homoscedasticity. It is wrong. It will be heteroscedasticity. So this is all about homoscedasticity and heteroscedasticity. You just know that if the residual versus fit, if it is scattered in nature, then that means the assumption of linearness, that is correct. But if it is not like that, if it is not scattered in nature, if it is like, if you notice some specific relationship between the fitted value and the residuals, then the relationship is not linear in nature. Okay, you need to fit some other kind of things, maybe quadratic or something else. So you can check out this video, the link that I have provided. You will get an idea for that, the non-linear thing. But again, this is not very easy, because there could be different non-linear things you can have. So now uh, another thing we are going to discuss, that is known as what is multicollinearity. Okay, so multicollinearity is when two of the independent variables are highly linearly related. Note that multicollinearity is not perfect multicollinearity. Perfect multicollinearity implies that the correlation coefficient is 1 in absolute value. Multicollinearity means that the correlation coefficient is high but not perfect between two independent random variables. Okay. And then the singularity in regression analysis, singularity is the extreme form of multicollinearity, when a perfect linear relationship exists between variables, or in other terms, when the correlation coefficient is equal to 1 or minus 1. What you need to know, that the term independent variable means an explanatory variable is independent of the error term, but not necessarily independent of the explanatory variables. So perfect multicollinearity means exact linear relationship between two or more explanatory variables, and imperfect multicollinearity means two or more explanatory variables are approximately linearly related, which we very often notice. So what is why we are discussing about this thing? We are discussing about this thing because in many models, for examples in structural equation model, you will see that multicollinearity does not it is not desired. Okay, because suppose when you are considering the effect of different independent variables on a particular dependent variable, the uniqueness of the independent variable is required in many cases or in many models. For example, in case of ACM or the structural model. So it is also checked whether there is a high correlation between the independent variables or not. Okay, if there is high correlation, then it may be assumed that uh, there also some relationship is exists. Okay, but let me tell you one thing, that we should understand that the correlation and causation are not two same things, which very often the students or people get confused. Okay, suppose I would like to just give an example. Suppose your independent variable is For example, the red meat consumption. And your dependent variable is possibility of colon cancer. Okay. So suppose you have found that there is a high correlation between red meat consumption and the uh, your mm, the uh, possibility of colon cancer. Okay, suppose you have found that. So it doesn't mean that the red meat consumption is the cause and the possibility of the colon cancer is the effect. Okay, it does not provide you that guarantee. It may be or may not be. Okay, because the relationship, it is just in many empirical research works, this kind of actually research works are done. Empirical research works are done for those cases where the people do not have much more idea about that. Okay, suppose if it is said that if it is asked that or if it is the technical reason or technical causation is actually found, then only it is termed as that there is a relationship, or sorry, there is, it is the cause and it is the effect. In this way we can say. Okay, so it may happen that red meat itself is not the cause of the cancer or the colon cancer, but the way it is cooked, the procedure of cooking may be the cause of the cancer. Okay, or there may be some other reasons. Okay, so it is not necessarily so it is not necessarily the relationship, it is not necessarily the cause. Okay, it is not the causation, it is not termed as the causation. There it may be or may not be. Okay, suppose you might have heard a lot of things about the smoking causes cancer. You have heard this sentence in when you go for watching movies, it is shown in the cinema hall or movie hall. You have seen that smoking causes cancer. This kind of statement is uh, given. Okay, why this is said? This is said because the smoking and the cancer, okay, or how much carcinogenic it is, so that relationship, it is tested, and it is found that there is a high correlation. Okay, it has been found in most of the surveys that there is a high correlation between smoking and cancer. But as long as any direct evidence is observed, it was not the case there. This smoking causes cancer, that kind of statement, uh, the government did not government or other agencies, they did not put. Okay, but after that, after once the this kind of empirical research work is over, then the causation or the technical reason, that is also tested, and it is found that really their smoking causes is causing cancer, and smoking, how the smoking is causing cancer, the technical reason, that has been revealed. Okay, that has been revealed by the scientists. So that's why nowadays it is said that smoking causes cancer. So what I would like to say, in case of smoking, the relationship between smoking and cancer, there is empirical evidence, and there is also the technical evidence is also there. But in case of when you are saying that red meat consumption and the colon cancer, this relationship, there is obviously the evidence is there. I mean, the empirical evidence is there, but the technical evidence, still now the technical evidence is missing, or there is no such technical evidence. Okay. So this should be keep this you must keep in your mind that the empirical evidence, it only gives you an idea that it may be okay, maybe that the red meat consumption it increases the possibility of this cancer, colon cancer, but you cannot provide guarantee, okay, because you cannot say the cause as such, as long as the technical reasons are not there. Then the autocorrelation and moving average. Okay, take a look at this slide. When you have a series of numbers where values can be predicted based on the preceding values in the series is said to exhibit autocorrelation. Okay. A moving average is a technique often used in technical analysis that smoothes price histories by averaging daily prices over some period of time, usually previous 3 days data. Okay. So basically auto correlation and moving average, we have, since we are discussing on the regression, we need to have the basic idea about auto correlation. Suppose we have talked about the independent variable and the dependent variable, but you can assume that in some cases the independent variable and dependent variable both can be same. If you consider in this way, then you may have the idea of autocorrelation. You may get the idea of autocorrelation. For example, suppose you have got a series of data, for example, a time series data you have got. Okay, and you can see that the in that particular data series, the previous values have an effect or a relationship with the current value or the present value or the future values. Okay, and the present values have some relationship with the future values. If these kinds of scenario occur, then the series or the data itself, it is regressed. Okay, the present values are regressed by the past values, or the current values has an influence of the previous values. So if these kinds of things occur, then we can tell that it is there is an auto correlation. And moving average is a technique where the previous usually 3 data you take, and the average values you also consider. The average value you take to predict the future value. Okay, so why this thing is important? Because suppose in these cases a lot of forecasting is done using uh, autocorrelation technique, or using moving average technique, or using, you will see that weighted moving average is used, or in some cases the exponential smoothing moving average technique is used. Okay, that means suppose weighted moving average means the the previous data, the recent past data, you give more weightage, and the far past data that you give less weightage. In this way you can give the weightage. Or suppose the in case of the exponential moving average, what you can exponential weighted method, what you can how you put your weightage, you exponentially, as you move towards the past and more past data, less weightage you produce. So in this way sometimes you treat. Okay, And I have also another slide, and if you can also go through on internet, a lot of materials are available on the forecasting techniques, different types of forecasting techniques, and there you will find that in that case the autocorrelation method, the moving average method, and both simultaneously when they are considered, that is known as ARIMA method. That means the auto regression and moving average, including both the techniques you use. Okay, the last three periods data's average value you take, and also the normal autocorrelation method, which is based on regression, that you also implement. Okay, so how to do all those things? Okay, so this you can just check out this link, and you can do that, how ER and MA models will be explained. You can take a look at some examples that how the things are done. Okay, so now we will discuss little bit on logistic regression. So the name is derived from a logit transformation. Okay, the log odds makes things symmetrical, easier to interpret, and easier for fancy statistics. Okay. Uh, for details, check out the following links. There's some links are given. You can check out the following links for to see the examples based on the logistic regression. Here the dependent variable in discrete and binary in nature, yes or no type, for example. Here two topics are focused: how to find out the coefficients with continuous x or independent variable, how to find out the coefficients with discrete x independent variable. Okay. So so far whatever we have discussed, we have seen that the dependent variable is continuous in nature. Okay. But I have already said, while I have discussed on the classification of different regression techniques, that apart from the linear regression and non-linear regression, there is also another type of regression which is known as the logistic regression, where the dependent variable will have discrete values. For example, yes or no type, or 0 or 1 type, these kinds of discrete variables you will get. You won't get any any continuous type of data, you will not get. Okay, so that is known as the logistic regression in that case. So just like the simple linear regression or the non-linear regression, what is your basic objective? The objective is to find out the coefficients for the independent variables and the constant terms. Okay, so here you will also do the same thing. You will find out the coefficients for the independent variables. Okay, but here two types of independent variables you can consider. Okay, in case of logistic regression, some independent variables can be can be independent, some independent variables can be uh, you know uh, discrete in nature. Okay, and some independent variables can be continuous in nature. Okay, and also in case of I mean in these particular things, or whatever, suppose I mean different types of combinations you may get. Okay, you may get your independent variables discrete in nature. You may get the dependent variables in discrete in nature. You may have some mixed kind of things. Some independent variables are discrete in nature, some independent variables are continuous in nature, or you may have some dependent variables are discrete in nature, some dependent variables are continuous in nature. So a lot of things you can get, lot of things you will be getting. Okay, uh, but you just what you don't need to know that how these values are actually being calculated, and in most of the cases manually you cannot calculate these values. Okay, so what you need to do, you just need to you should know that how to use the Minitab, and you will find, you will, if you go through the YouTube videos, you will find a lot of examples are given, and I have also provided you different links I have provided. You can go through those links, and using those links you can you can get the ideas that how actually you are you will be uh, getting the values of those coefficients. Okay, it will be automatically, the values will be provided by the software itself, so you don't need to worry about it. Okay, but still to get some inner sight, I am just discussing these things, but these are not required for your actually examination purpose. These things are not required, but still to give you some insight about it, I am just discussing those things, that how it actually works. That logistic regression predicts whether something is true or false instead of predicting something continuous like size. Okay. Also, instead of fitting a line to the data, logistic regression fits an S-shaped logistic function. You have seen that in case of the linear regression, a particular a best fitted line you have seen. Okay. But here in this case, instead of a best fitted line, logistic regression fits an S-shaped logistic function. Okay. This you can see. So now there is one particular example is given. Here you can see that along x-axis, the weight is represented, weight of a different mouse. Okay. So that is represented, and along y-axis, there are only two outcomes. Uh, Obese, mouse is obese or mouse is not obese. Obese uh, is a disease which is related to the weight. Okay, and from the data you can easily understand that the mouse which that have more weight, they have higher tendency to be obese, and the mouse that have lower weight, they have less tendency to be obese or not obese. Okay, so now this curve goes from 0 to 1. So is not obese, it is 0, obese it is 1. Okay, so first, suppose if you get some point, suppose if you are asked that, for example, the weight of a mouse is this. Okay, if this X value is given, and if you are asked that what is the probability that the mouse will be obese. So you can easily understand that from here, if you vertical, if you move upward, it will cut here in the S curve. Okay, and if you see here, if you take the this y value, then it will be, you can see that there is only 50% chance that the mouse is obese. Okay, so curve tells you the probability that a mouse is obese based on its weight. Okay, logistic regression doesn't have the same concept of a residual, so it cannot use least square and it cannot calculate R square. So the way the logistic regression provides you the values of the coefficients, it's not based on the concept of the residuals. Okay, because here you are not getting a straight line. So you won't be able to calculate the least squares, and here also you cannot calculate the R square. Okay, or the correlation coefficient of the determination, that R square you cannot find out here. Okay, so it actually uses something called maximum likelihood. I have given you the concept of maximum likelihood earlier. Okay, when I discussed about the distribution. Okay, suppose there is an exponential distribution. Okay, why maximum likelihood is used? Maximum likelihood is used to check out that for a given particular data, you know that what distribution it will fit, but what will be the exact shape of the distribution? Okay, or what will be the exact shape of the S shaped logistic function? Okay, in order to understand that, we use the maximum likelihood function, which is also being will be used in this particular case. Although logistic regression tells the probability that a mouse is obese or not, it's usually used for classification. Okay, that means though it will give you the probability, suppose 0.4 or 0.6, like that, you can understand if it is 0.6, you consider it dichotomously. If it is 0.6, then you will understand that the mouse will be obese. If it is 0.4, you will say that the probability is that the mouse will be not obese. Okay, in this way it is usually used for the classification purpose. Okay, the same thing it is discussed. For example, if the probability of mouse obese is greater than 50%, then we will classify it as obese. Otherwise, we will classify it as not obese. And you can see that here only along x-axis the weight is given, only one independent variable is shown, but instead of one independent variable, you may have more than one independent variables. For example, obesity may be predicted by weight plus genotype plus age plus astrological sign. Just like linear regression, logistic regression can work with also continuous data. Like for example, the weight and age, these are the continuous, and the discrete data like genotype and astrological sign, they are discrete in nature. So you can see that there are four independent variables, and out of these four independent variables, there are two independent variables are continuous in nature, and two independent variables are discrete in nature. Okay, and we just test to see if a variable's effect on the prediction is significantly different from the zero. Okay, so obesity is predicted by this. If not, it means the variable is not helping the prediction. Okay, this is actually based on hypothesis testing, which we will discuss later, and it is we use Waltz test to figure out this. Okay, and in this case we have, if it is something found which is not statistically significant, so that we can eliminate from this from the equation. So we can or from the model actually. So we can here suppose astrological sign, you have found that it is not actually it is not statistically significant. So what you will do, you will just leave it out from your model. You leave it the astrological sign, and obesity will be predicting by weight, genotype and age only. Okay, so here in this way we can save time and space in our study by leaving it out. Okay, so then these things we will be discussing in tomorrow's class. Okay, so now I am going to stop the recording.